Hello everyone, I'm Praveen and I'm going to demonstrate my technical seminar that is Speech Emotion Analyzer. And me and Mangala Gauri are going to demonstrate this project. So basically, this is nothing but with a given number of speech that is based on the data sets which we have collected, which I'll be showing it to you soon. So based on those data sets, where we collect them and we train those data sets and those models by building them using the CNN model, that is convolution neural network. So based on all those data sets, we can make the program analyze and produce output that whether the expression is happy or sad, and with based on the numbers which we have allotted. So let us go with the libraries which we have used. So let me just take you to the libraries which we have used, the main libraries which we have used. So one is the first one is Librosa library. That is, it's an extraction feature where it's mostly used for the audio analysis, where based on the number of audio files which we have collected, we use that for we actually keep a timer for about 3 seconds, so that each and every audio file is being extracted, and then we analyze all the audio files. And it also doubles the sampling frequency, where the audio files has been extracted thoroughly, and it also depends on the size of it. So this is the Librosa library, where it extracts most of the features, and NumPy is based on the numbers which we wanted to use. And TensorFlow is it's basically used for a complex computing. So for example, which if we have a lot of numbers which is present there with so many with a lot of data, so we need a certain library where we can we can compute the numerous number of numericals which can be calculated using the TensorFlow library. And Keras is also an open source neural network library which is actually used running on top of the TensorFlow. So for TensorFlow we also need Keras, so that we can use for basically it's used for a faster experimentation, and it focuses mostly on the modulars and the different extensibles. Now after the brief explanation of those libraries, so let me just go through the program. So yeah, we have installed the Keras library, imported them, and yeah, so we have something called the raw data. So it's a file where I have stored it over here. So there's a folder that is the raw data folder, where I have stored all the audio files inside them. So we have two kind of data sets. So one is the RAVDIS, that is Raisin audiovisual database of emotional speech and song. So that's one data set, and there's another data set that is the SAVI, that is survey audiovisual emotion. So in RAPDIS, where it's also a dataset where it includes around 1,500 audio files, which has 24 different actors, and so it's equal. So 12 are male, 12 females, and based on the emotions I have numbered them. That is 1 as neutral, 2 as calm, 3 as happy, 4 as sad, 5 as angry, and 6 as fearful. And 7 is disgust, and 8 is surprise. So there are different emotions for different numbers which I have allotted. And there's also another file, that is the another data set, that is SAVI, where there is around 500 audio files which is recorded by 4 different actors. And it is also used for the emotions by that is based on the expression, or how they portray the given expression which they speak. So these are the total number of audio files which we have, that is around 500 plus 1500, so almost like 2000 plus audio files. So these are the data sets which our program is chosen, and based on this data set we proceed to just check the emotion of the particular user. So we have also plotted the the waveform and the spectrogram based on the data set which we have on the raw data file. So this is the waveform for one particular audio file where the where the sampling data has been selected, and it has been plotted based on the decibels and the voice of the particular actor which they have produced the audio. And yeah, and this is the spectrogram where we use one of the wave file based on the wave file which we have from the raw data, that is from let's say like we have taken F10 with 2.wav, that is the file which we have selected, and also plotting the coordinates and applying the actual color and the intents for the particular file, and it's been plotted. And yeah, so this is the this is the data set which I'm talking about, where we have allotted for each and every number has been allotted for one particular emotion, that is female calm, female happy, male happy, and based on the type which we have, we also numbered them. And similarly for the male also, so for the male and both the male and the female, so this is it, and it's been labeled. So the same thing which is present there, we have just made it as a table to just show what are the different kinds we have. And yeah, this is the Librosa library where I've already explained before, that is the extraction feature. So each number is been it's been given for every, so each number is given, so for example 6 1, yeah, so every number is been allotted for different expression, and this is the feature which is produced over there. And the table is also created. So this is the table for the extraction feature, which we have almost around like 215 columns. Okay, 215 columns almost. And yeah, so we have also taken all the datas which is produced over there, and we have to even train all those data. So we have almost around 250 rows and 260 columns, so with their frequencies and its new numbers. So for this we also need it also has a complex computation. So it starts extracting all these features and allocating it together. So this is the dimension of the CNN model, that is the convolution neural network. We also built a multi-layer perceptors and long short-term memory models, and but they performed under with very low accuracies, which couldn't pass the test while predicting the actual emotions over there. So we have also built the tune. We also built and tuned the model for the consuming process. And the idea why we have done is to start with small, like we started adding with small layers, and for the sake of making it complex, after testing out those layers, the model which gave the maximum validation accuracy against the test was about like 70%. So so this is a graph. Like before that, I'll just come here. So yeah, so this is the CNN model which we have produced, and so this is a table which is formed there. So the activation, the dropouts, and the convolution 19. There are different type of the data which is brought up over there. So yeah, so this is the epoch list where we have to train. So we have to train all these data sets. So which is about 2349 data sets which is available there, and then we have to train them 700 times. So which took me like almost like around 3.5 hours to train each and every data sets, which took around 60 seconds each file. So to just make sure that the expression which is given there, we have to keep loading the system, saying that yes, this is happy, yes, this is sad, and so this is what the training is about. And this is the data which is this is the CNN model which we have used, so that we can make it so we can add more layers into the model. So this is the So this is the training graph, and this is the test graph. So there's a little of deviation over there. So so the model which we have the model which we have used over there. So we have to save the model, and then later we have to load this model. So yeah, the model has been saved based on the data which we have selected, and also the model has been loaded. So once the data is saved, and it's ready to load the data, so the accuracy is about 65.79, which is almost around 70%, which we wanted. And yeah, so now we are going to predict the test data. So based on that, we have made a lot of tables, and then the confusion matrix. Yeah, so we also have the, like, based on the data which we have, we also predicted the values, and also the actual value. So this is the predicted value with the tabular column, and the actual values, and then now it's going to be the prediction versus the actual versus the predicted value. So there's another feature, that is the live demo. So where I'll be recording myself for about few seconds, and based on that I'll be providing you the respective waveform and its expression of tone. So I'll just show you how it works. So I'll be using two libraries, that is the PyAudio and its Wave. So PyAudio is nothing but in Python, if I want to use anything audio related, so I have to use PyAudio. So I have installed it, and also the Wave, that is the audio file format. So both are imported, the chunk size, the channel, yeah, and then the rate, and the record seconds is about 4 seconds, and I've named the file as output10.wa, which I'll be showing you in the folder. And I'll be providing you with the prompt as recording, and then after 4 seconds of the chunk and the record size, it ends it automatically, and completes the recording. So I'll be showing how it's going to be. So I'll just record this. Hello everyone, I'm Praveen. So yeah, so the recording is done. So I'll just show you where it's going to be saved. So we have this folder, that is output 10. So based on this, I'll be showing you whether, so you'll just be hearing the same output. Hello everyone, I'm Praveen. So yeah, so this is the audio file which I have just recorded right now, and so I'll be using this file, audio file, into this program to just check the waveform and its expression. So let me just run this. Let me just run this file. Okay, and using the extraction features. So this is my waveform which is produced right now with my voice, which it has been analyzed, and based on the CNN model and the model which it has on the previous datas, it compares and it produces the respective output. So using this sample rates and the extraction features, it will give me certain tables to just check how the features has been extracted using the Librosa library. And yeah, so this is the table which is formed. So yeah, thank you.